This video will demonstrate how to locate faults when a drainage pipeline has failed an air test, and should be viewed in addition to our short video of how to conduct an air test on Hepworth Clay drainage systems up to 300 mm in diameter. After jointing a pipe, be aware that certain external environmental conditions can also affect the test, contributing positively or negatively while the test is underway, contributing to a false result, such as the water or U-gauge level rising. This occurs when the sun shines on the pipeline, increasing the temperature of the air inside the pipe and expanding it as a result, raising the water gauge measurement level. The water gauge level falling. This occurs when the pipeline suddenly goes into shade, or a sudden rain shower falls on the pipeline, decreasing the temperature of the air inside the pipe and contracting it. The water gauge level fluctuates. This occurs when the events described before happen alternately, or on a windy day, gusts of wind will vary the air pressure, causing the water level to fluctuate. These phenomena can happen in a very short time period. Having excluded the environmental conditions or taken them into consideration, you should then move on to checking the testing equipment more closely. Here are a few suggested things to check depending on the type of failure experienced. Check for major faults and even basic oversights, like not stoppering off all branch connections and forgetting to put in or tighten the stopper or fit the end cap at the other end of the pipeline. Does the manometer or water gauge have water in it to the correct level? It is easily knocked over and can lose the water inside, which may not be readily noticed. Now we are looking for less obvious faults. The equipment may be in place, but could be a very poor fit. This is the most difficult type of fault to determine, and often the pipeline is blamed for the fault at this point. It is much simpler and easier to check the testing equipment first. Check each testing component sequentially. The water gauge level rises, but during the test period falls below 75 mm in 7 minutes. Ensure that all the equipment is clean and in good condition. Check that the stopper rubber seals don't have any surface cracks and the end caps are tight. Connect the testing equipment to a short pipe and submerge each part underwater in turn, or completely, to identify any leaks where air bubbles escape. This rubber tubing has a hole in it, but it could be cracked or split, and the stopper is poorly fitted. The bung may have surface cracks in the rubber, or it may not be tight enough. Some steel-plated stoppers can be deformed by over-tightening, and not compress the rubber stopper adequately to provide a seal. The pressure pump can also be a cause of air leakage. Pinch one end of the pump tubing and pressurize. Check for air coming out of the pump. And check that any valve or clip is in place, closed and is working correctly. Use dilute washing up liquid to identify any air leaks from the testing equipment by liberally coating all connections with the fluid and correcting any issues found. If you still can't get a test to hold, then visually check the pipeline to ensure that all of the joints have been made correctly, and by coating any suspect joints liberally with the fluid to check for leaks. Remember, the leak may be found anywhere on the seal contact area, typically where it's hard to see and locate. It is recommended that you only install a few pipes before applying a quick intermediate air test check, so that you do not have to remove too many pipes to get back to the point in the system where the pipeline will hold a test. Checking that pipeline jointing has been done correctly as you go. Replace any defective couplings if found, and remove them from the work area so that they can't be reused.